No.
Okay, I already discussed what this is going to be, binomial expansion with and without Pascal's triangle. Look at that. Alright, so the purpose of binomial expansion, say you have this expression 2x minus 3 to the fifth. Now what you could do is you could FOIL it, FOIL it, FOIL it, but somewhere you're going to lose a number and you're going to end up getting the wrong answer, at least for me at least. So there are two better ways to do it, quicker ways that will give you the right answer quicker and the better chance of getting it accurate. There's the binomial expansion formula, which we'll talk about later, than Pascal's triangle, which will make it very easy to find coefficients. So first, before we do that, we need to learn the concept of what a combination is. That's actually from probability. All math is connected, yay. So in order to find this, we need to find it. You can do it really easily on your calculator. Every calculator is different, but there's going to be some sort of math button and then a probability button, and what you're going to do is hit NCR that's for the TI-84. Go to hit math and then go over to probability on the right hand side and then hit 3. But whatever button says NCR, that's what you're going to hit to find it. And this number is going to be the coefficient of the term that you're finding. So this is the binomial expansion formula. Yes, a lot of numbers, it's not as tricky as it looks. So n is the exponent, so n is what we're going to put for the top part of the combination. This just means that combination k. And to find the exponents, you're going to do n minus k. K starts at 0. So as we count up, say the third terms, k is going to equal 2, 0, 1, 2. So b, or usually you'll see y, will be raised to the second. And then this will be raised to whatever the initial exponent is, minus k. And this is just in case that you are unable to find it on your calculator. This is the formula for finding combinations, but that's unnecessary. Alec.
What does that exclamation mark mean?
That means factorial.
What is factorial?
You don't really have to worry about this. This is if you can't do it on your calculator, but pretty much everyone here can. Just handy formula. So now let's try a problem. So we have x plus y to the 7th. We're going to have 8 terms in this expression. Remember, this number is n. You're always going to have one more than n number of terms in your expression. So let's find the first term. We have this formula again, a to the n minus k times b to the k. So that n equals 7. K, since it's the first term, is going to equal 0. I already said that it always starts at 0. So 7 choose 0 and choose k is equal to 1. So we have 1 times x to the 7 minus 0 and minus k times y to the 0, which is k. Who knows anything to the 0th power is 1. So we have x to the 7th times 1, which is obviously just x to the 7th. These are just the rest of the answer to this question. You see another one. This time it's 6 choose 1. 6 choose 1, because it's n minus k. So then k. So 7 times x to the 7 minus 1 is 7x to the 6th y. And these are just the rest of the answer choices. You'll see that the coefficients are palindromic. It means they're the same forward and backwards. That's something that you'll see in Pascal's triangle. So we get into that right now. So, like I said, the easier way to find the coefficients than even doing the binomial expansion formula is Pascal's triangle. This is Pascal's triangle right here. You're going to go to whatever row you need, and that row is determined by the exponent you're raised to. Big warning sign, many people think that this is row 1. It's actually not, it's row 0. So if you want to find something x plus y to the 4th, you have to go row 0, row 1, row 2, row 3, row 4. If you have x to the 4th, and that means you're going to have 5 terms, coefficient for the 1st, for the 2nd, for the 3rd, for the 4th, for the 5th. If you need to make your own Pascal's triangle, like on a test or something, it's not given to you. It is the sum of the two numbers above it. So you can see 1, 1, 2, 1, 2, 3. It's the sum of the two numbers. So let's practice with Pascal's triangle. Similar, actually same exact question, x plus y to the 7th. We go row 7, row 0 first, 1, 2, 3, 4, 5, 6, 7. And then those straight across the board are the coefficients, 1, 7, 21, 35, 35, 21, 7, and 1. Now you just have to find the terms of the expression. And to do that, we have to remember this x to the n minus k times y raised to the k. Remember, n is that exponent being raised at the beginning, 7. So this, you're going to get a very long, messy looking answer whenever you do anything like this. But this is what it's going to end up being. These coefficients are tacked on to the end. And then as you can see, if you look at the x term, 7, 6, 5, 4, 3, 2, 1, 0. The exponent for that, and the y, 0, 1, 2, 3, 4, 5, 6, 7. That's how it's going to end up being. Now you have coefficients within the parentheses. This is where it gets really fun. Take the exponent 2x plus 3y to the 5th we have. Now you can't just treat this as this x and then, oh, we're going to slap a 2 on it at the end. When you raise this power, like we did before, you're going to have to raise the 2 as well. So that's something that tricks a lot of people. So let's use Pascal's triangle, it's just easier. We have it to the 5th term, we go row 0, 1, 2, 3, 4, 5. 1, 5, 10, 10, 5, and 1 are our coefficients. First term, 1, times 2x to the 5th times 1. So it's not 2 times x to the 5th, it's 2 to the 5th times x to the 5th, which is 32 times x to the 5th. As I said, you have to treat the 2x as one single term, not a term with a coefficient slapped onto it. At the end, like I said, they're going to be very, very messy answers, but this is how it is. It's worked out. 2x to the 4th equals 16 x to the 4th, and you just have to do it for every single one. Is it fun? No. Is it necessary? You don't want to do foiling for all of that. And that's about it. So if anyone has questions, Alec.
So more often than not, would you find yourself using a binomial theorem or a Pascal's triangle?
Pascal's triangle is easier, and if you know how to make it yourself, like I said, with the sums of the two above it, then that's easier to do just because you have the coefficients right there. But if you don't, and you don't remember how to use Pascal's triangle, you're not completely lost. You can use the theorem.
The previous question, do you treat the 3y as one
Yes,
term?
that's also one term. But
Okay.
I just used the 2x as an
Yeah,
example.
yeah.
But every term, you treat it as one term.
So you would have to do 3 to
3 to the 4th or whatever term that you're working on, yes.
So you use the 3.
Like I used it right here. 3y to the 3rd is actually 27y to the 3rd. 3 cubed, y cubed.
Because you have to do the 3 to the 3rd and the y.
Correct.
Okay.